writing equations for perpendicular lines is much like writing equations for parallel lines, except this time, instead of the slope being the same, slopes of perpendicular lines are opposite reciprocals. So first I'm going to present a geometric argument as to why that is true. Consider this orange line here. Well, this orange line has a slope, and if we just pick 2 points on this orange line, maybe this point and this point, and we see that I can represent the slope as this distance divided by this distance. Let's call this distance right here delta y, or change in y, and this distance delta x. Then the slope of the orange line is the rise over the run, which is delta y over delta x. So now imagine that I sort of grab a hold of this line and turn it 90 degrees, keeping this point here in place. Well, if I turn this line 90 degrees about this point, then I get this line here. So imagine that I turned the orange line onto the blue line. Well then, this point now is here. And it's like this triangle turned like this. Now, this distance delta y is right there. That distance is still delta y. And the reason for that is that our rotation is an isometry. The length here, delta x, that's right here. This is still delta x. Now let's think about the slope of the blue line. The slope of the blue line is clearly negative. It's going down from left to right. So the slope of the blue line is negative, and then the rise is delta x, and the run is delta y. So it's negative delta x over delta y. Okay, so now I think it's clear that the slope of the orange line and the slope of the blue line, well, they're opposites and they're reciprocals. Another way that you'll see this, another way you can check to see if two lines are perpendicular is if the product of their slopes is -1. So let's multiply the slope of the orange line times the slope of the blue line. The slope of the orange line is delta y over delta x, and let's multiply that by the slope of the blue line, and the slope of the blue line, multiply this by negative delta x over delta y. Well, the delta y's cancel, that's just 1. Delta x is canceled, that's just 1, so what's left is exactly -1. So that's two ways you can remember how the slopes of perpendicular lines are related. Either they're opposite reciprocals, well they are opposite reciprocals, or the product of their slopes has to be -1. Okay, so let's work an example. I hope this argument was convincing. Okay, so let's say we have the line 3x minus 4y equals 5. So find the line perpendicular to this through the point, 2, -4. Okay. So let's look at this line and let's rewrite it in slope-intercept form so we can find the slope of this line easily. If we subtract 3x from both sides, we find that we have -4y equals -3x plus 5. And then divide everything by -4, we have y equals 3/4 x minus 5/4. This minus 5/4 is inconsequential to us. We don't really care about it. All we really care about is that the slope of this line is 3/4. That means the slope of our line that's perpendicular to this line and through this point, has to have a slope of -4/3. So we start writing our equation. Y equals -4/3 x plus b. Now I'm focusing here on slope-intercept form. If you're working with point-slope form, you can just plug in this point using that slope. But I'm going to work with slope-intercept form. So we know that our equation has to be of this form, y equals negative 4/3 x plus b. That is because 3/4 and negative 4/3 are opposite reciprocals. The product of those two numbers is negative 1. Okay, so plug in this point for x and y here. The y value has to be negative 4 precisely when the x value is 2. 2 times negative 4/3 is negative 8/3. So I have negative 4 is negative 8/3 plus b. To solve for b, I add 8/3 to both sides. So I have negative 4 plus 8/3 is equal to b. Negative 4, I need to get a common denominator here to do this addition. This is negative 12/3. So negative 12/3 plus 8/3 is equal to b. This implies that b is negative 4/3. That's kind of neat. All right, so our line then is y equals negative 4/3 x minus 4/3. Y equals negative 4/3 x minus 4/3. Okay, so that's how you write equations of perpendicular lines.